السلام عليكم ورحمة الله وبركاته. ميرو نصرور chemistry teacher.
Our topic today is balancing oxidation-reduction equation.
It is a reaction in which one or more electrons are transferred. As example, if we have a chemical reaction occur between two elements, M and X, what will happen when electron or more transferred completely from element M to element X? M will change into positive ion, but X change into negative ion. This is the redox reaction. We can conclude this chemical reaction in this table. M will be oxidized, meaning losing electron or more, meaning oxidation state increase. X will be reduced, meaning gain electron or more, oxidation state will decrease. M will be reducing agent, mean electron donor. X will be oxidizing agent, mean electron acceptor. Oxidation number. It is the number of electrons that must be added to or removed from an atom in a combined state to convert the atom into the elemental form. Rules of assigning oxidation state. As example, find the oxidation number of a sulfur atom in a pyrosulfate ion, C2O7 to negative ion. This is the symbol of the pyrosulfate ion. The state number, oxidation number of oxygen is -2. So now we can calculate the oxidation number or oxidation state of sulfur. Oxidation number of oxygen equal -2. Sum of oxidation states equal charge of the ion in ions. So -2 equal 2 times x plus -14. So x will be +6. So the oxidation number of sulfur equal +6. Balancing oxidation-reduction reaction by oxidation state. This is the rules that we will apply now in front of you. Example, balance the reaction between solid zinc and aqueous hydrochloric acid to produce aqueous zinc 2 chloride and hydrogen gas. What is the unbalanced equation? Zn plus HCl give Zn 2 positive ion plus chlorine negative ion plus H2. What are the oxidation state for each atom? Zn is a solid, pure atom, so its oxidation state is 0. Hydrogen is +1, chlorine is -1. Zn carry 2 positive charge, so it will be +2. Chlorine carry 1 negative charge, so its oxidation state is -1. Hydrogen gas is a pure element, so its oxidation state is 0. How are electrons gained and lost? We can see that zinc was oxidation state 0, it changed into +2, so there is a 2 electron lost. Hydrogen changed from being +1 oxidation state to a 0 positive state, so 1 electron gained for each atom. What coefficients are needed to equalize the electrons gained and lost? In this case, there is only 1 electron gained in each atom, so it must be multiplied by 2 to equalize number of electrons gained or lost in this equation. So in this step, Zn plus 2HCl will give Zn 2 positive ion plus Cl negative ion plus H2. What coefficients are needed to balance the remaining element? We added the coefficient 2 for HCl to equalize number of electrons gained by hydrogen to to change into hydrogen gas. So the same coefficient must be added in front of chlorine to equalize the number of atoms of chlorine in reactants and product. Very good. The equation now is balanced. Exercise. You have to apply these rules by yourself. Thank you for trying. Balancing equation of oxidation-reduction reaction by half reaction. The overall reaction is split into two half reactions, one involving oxidation and one involving reduction. As example, this is equation 8 hydrogen ion plus MnO4 negative ion plus 5 Fe2 positive ion give Mn2 positive ion plus 5 Fe3 positive ion plus 4 H2O. To split this reaction into two halves, we have to identify the change occur in each element in this equation. Mn change from being have oxidation state 7 positive into 2 positive. So what happened? Oxidized or reduced? Good, it reduced. It is a reduction reaction. What happened to iron? Iron change from oxidation state 2 positive into 3 positive. So what happened? Oxidized or reduced? Good, oxidation. So we can now split the chemical reaction into two halves, reduction and oxidation. In the half reduction equation, Mn change from being 7 positive into 2 positive. In oxidation half reaction, iron change from being 2 positive into 3 positive. The half reaction method for balancing equation for oxidation reduction reaction occurring in acidic medium. There is a rule we have to apply to balancing the reduction reaction equation in acidic medium. Number 1, write separated equation for the oxidation and reduction half reaction. For each half reaction, balance all the elements except hydrogen and oxygen. B, balance O using H2O. C, balancing H using hydrogen positive ion. D, balancing the charge using electrons. 3. If necessary, multiply one or both balanced half reaction by an integer to equalize the number of electrons transferred in the two halves reaction. Number 4, add the half reaction and cancel identical species. Number 5, check that the element and the charges are balanced. Now we have an example. How can we balance this equation? Cr2 O7 2 negative ion plus SO3 2 negative ion give Cr3 positive ion plus SO4 2 negative ion. In front of you, the equation, we have to separate it into two halves, reduction half reaction and oxidation half reaction. So we have to calculate and find the species that has been reduced and the species that has been oxidized. As we can see, chrome change from oxidation state 6 positive into oxidation state 3 positive, so it reduced. Sulfur change from being having oxidation state 4 positive into oxidation state 6 positive, so it oxidized. So the two half equation in front of you. The first one, the half reduction. The second one is the half oxidation. The next step, balancing element except hydrogen and oxygen. Now we have to apply the conservation law of mass in any element except oxygen and hydrogen. In the first equation, there are 2 chrome atoms in reactants, but only 1 atom in product. So we have to multiply the product by 2 Oxygen in the second equation will be balanced next. So the two equations will be as we can see now. Balance the charge using electron involved in each half reaction. The first equation must add 6 electrons to transfer chrome from being Cr2O7 to negative into 2Cr3 positive. And in second equation there will be 2 electrons produced during two changing SO3 to negative ion to SO4 to negative ion. As we can see in these two equations. Next step, balance the oxygen atom. We can balance the oxygen atom by adding water molecules. The first equation must put 7 2H2O 7 molecules of water to balance the amount of oxygen, because we have 7 oxygen in the reactants, so we have to add 7 oxygen in the product, so we have to add 7 H2O molecules. For the second equation, we have in the product increase 1 oxygen atom, so we have to put only 1 water molecule in the reactants. Next step, balance the hydrogen atom in an acidic solution. Now we have to balance the hydrogen gas that we put in form of water, 7H2O in product, so we have to add 14 hydrogen ion in the reactants to balance the number of hydrogen in product and reactants. In the second equation, we have to put 2 hydrogen ion in the product to balance the amount of hydrogen added in the reactants. Balance the electron. The first equation contains 6 electrons. The second equation has only 2 electrons. So the second equation must be multiplied by coefficient 3 to give the same number of electrons in the two reactions. After multiplying the second equation by 3, now we can add the two half equations to each other to find the final balanced equation. This is the final balanced equation. We can check the number of atoms and the number of charges in this equation. At the beginning, we check number of atoms in reactants and the product. In reactants, there was 2 chrome atom and the product contained 2 chrome atom. There is 16 oxygen in the reactants and 16 oxygen in the product. Sulfur only 3 atoms in reactants and the product. Hydrogen 8 atoms in reactants and the product. So we achieve the conservation law of mass, because number and the type of atom in reactants equal number and the type of atoms of product. Now we check the charge. The first species carry 2 negative charge and the other carry 2 negative charge multiplied by 3, and the last one has positive charge multiplied by 8. So the net charge is 0. In reactants, in product, chrome charge is 3 positive multiplied by 2, and sulfur has 3 species multiplied by 2 negative, so the net charge only is 0. Very good. The equation now is balanced. Exercise. Please try to balance it by yourself. Thank you for trying. The half reaction method for balancing equation for oxidation-reduction reaction occurring in basic solution. Number 1. Using the half reaction method as specified for acidic solution to obtain the final balanced equation as if hydrogen ion were present. Number 2. To both sides of the equation obtained above added a number of OH negative ion that is equal to the number of positive hydrogen ions. We want to eliminate hydrogen ion by forming water. Number 3. Form water on the side containing both hydrogen ion and OH ion. and eliminated the number of H2O molecules that appears on both sides of the equation. Number 4, check that elements and charges are balanced. Balance the following oxidation-reduction reactions that occur in basic solution. Cr plus CrO4 2 negative ion give CrOH3. At the beginning, we have to identify the species that oxidized and the species that has been reduced. In front of you, the solid Cr atom changed from oxidation state 0 to oxidation state 3 positive. So Cr is in this species is oxidized. In the another species, chrome changed from oxidation state 6 positive to oxidation state 3 positive, so it reduced. Step 1 separates the equation into two halves reaction. The first one is the half oxidation reaction. The second one is the half reduction reaction. Step 2, balance element except hydrogen and oxygen. The only species now have to be balanced is chrome. In the two equation, it is already balanced. Step 3, balance the charge using electron involving in each half reaction. The first equation is oxidation half reaction, so we have to add 3 electrons in the product. The second one is the half reduction, so we have to add 3 electrons with the reactants. Balance the oxygen atom using H2O molecules. In the first equation, we have 3 oxygen atoms in the product, so we have to put 3 water molecules in the reactants. In the second one, we have 4 oxygen molecules in the reactants and 3 oxygen molecules in the product, so we have to put 1 water molecule in the product. Step 5, balance the hydrogen atom in an acidic solution. We added 3 molecules of water molecule, so the product must be contains 3 positive hydrogen ion. We added in the second equation 1 water molecule, so we have to put 5 hydrogen ion in the reactants because there is 3 hydrogen molecule in this species. Step 6, balance the in the first equation, chrome loses 3 electrons, so we have to put 3 electrons in the product. In the second equation, chrome accepts 3 electrons, so we have to put 3 electrons with the reactants. Step 7, add the half reaction to get final balanced equation. After adding the first equation to the next equation, we can find this net equation. But this equation is balancing redox reaction in acidic medium. At the beginning, we said that we needed to balance this equation in basic medium. So we have to balance the hydrogen ion by adding a number of OH ion that is equal to the number of hydrogen ions in this equation. So in the net equation, we must add number of hydroxide ion equals the number of hydrogen ion exist in the equation. In the net equation, we have only 2 hydrogen ion in the reactants, so we have to put 2 hydroxide ion in reactants and 2 hydroxide ion in the product to balance this equation in the basic medium. So the final balanced equation for H2O plus Cr plus CrO4 2 negative ion give 2CrOH3 plus 2OH negative ion. Now we have to check number and type of atoms in the reactants and the product and the charge in reactants and the product. We have in the reactants 8 hydrogen atom and in the product the same number. Chrome in the reactants 2 atoms, in the product 2 atoms. Oxygen in the reactants 8 atoms and in the product 8 atoms. So we achieve the conservation law of mass because number and the type of atom in reactant is equal number and type of atom in the product. To check the charge, the only species that carry charge is this species carry 2 negative charge, and this 2 multiply by 2 only 2 negative charge, so the net charge is equal in reactants and products. So now very good, the equation now is balanced. Exercise, please check your understanding and try to solve this exercise by yourself. Until see all of you again, goodbye, thank you very much.